Okay, so this circuit right here, I've got all the parts I need for it right here. Relay 1, which is this one, is right here. Relay 2, which is this one, right here. Relay 3, which is this one. It's right there. Relay 4 are these two. And S2, which is that switch, and that switch is right here. And and I'll be using my oscilloscope for the screen. What this circuit really is it's, I don't know if I'll find it. So what I'll have is I'll have this potentiometer, I'll have these two leads right here connected to a battery, and I have the sweeper connected to one end of the yoke coil, and I have the other end of the coil connected to the middle of the two batteries. So when this sweeper goes back and forth, it will make the dot go back and forth. So this is really just a crude version of Pong, except you can't move the paddle thingies. You can actually win or lose in this game. And what determines if you win or lose is this right here, which is relay 4. What it is that 120 volts will be put across that cap, 120 volts AC, which is going to be supplied by these two transformers. And when switch 2 is pressed, the AC will stop being fed to the cap, and because AC is basically just a sine wave and there's positive and negative peaks, the charge on that cap will either be positive or negative. So, and I'll have a diode across it, so if it's positive, it'll be able to go through and turn on the relay, but if it's negative, it won't be able to go. And that's what will determine if you win or not, just if that cap is charged positive. I'm actually pretty proud that I came up with that. I think that's a really neat thing right there. All the rest of this, really, it just makes it a game, but I'm personally I really like this right here. All I have to do is really just wire it up, and that might take a little bit. So I guess that's maybe let me explain this how it works. Let's assume this relay is on, this relay is off. You lift up S2, and the charge on the cap is negative, so this relay doesn't turn on. The motor will start moving this way, and when it touches this wire, the relay turns back on and it starts moving this way. And if you don't press S2 fast enough, it will hit this motor right here, will hit this contact, and it will turn this relay on, and it will take away the electricity from the relay, turning it off, so then it will start moving this way again. Now, but it also turns off the power to the whole thing. And how it does that is because I have a capacitor right here connected to this relay, which is relay number 3, right here. And even if the power is turned completely off, that capacitor will keep that relay on for a certain amount of time. So it will just return to center instead of being stuck on this contact, because if it's stuck on that contact, the next time you play it, it won't be able to work. Okay, so let's assume this is going back. Let's assume that you pressed this and it didn't hit this contact, and now it's going this way. Oh wait, I take that back. I'm sorry, this is really confusing. Let's start from the beginning. Okay, let's say that this relay is on, and you lift up S2, and so you take the charge from the capacitor off AC, and let's say that it's positive, and then you touch right here, and it turns this relay on. So when the motor starts moving this way, okay, what this does when it's turned on is that these contacts go, and it goes across these contacts. So and these contacts right here makes this wire from this relay connect to this contact, so when it touches, it turns this relay on so that no power goes to the circuit, and because these two contacts here are closed, when the power is turned off, these two contacts are still together, so the motor will actually move this way instead of this way. And that's what will return it to center again if that happens. God, I'm so sorry, I just can't explain this right now. I'm just gonna say that's it, because I can't explain this.